So you might see that I've been wearing the same shirt for a little while now, and the reason for that is because I'm filming many videos in the same day. But what can you do? So anyways, we're talking about data structures today, so let's get right into it. Full name of this class is Data Structures and Algorithms, and if any one of you is in my university, maybe in other universities as well, you're going to be really scared of this class because at my university this class is really famous, or maybe infamous, for being really difficult. It is probably the second or third class that computer science students at my university will have to take, and it's really hard. But it's a lot of fun as well. Funnily enough, it's actually a class that I have actually TA'd in twice because I've enjoyed the content so much. So what is data structures and algorithms? So I'll start off with describing those two terms first, right? So algorithms basically, in a way, for me at least, is just a set of instructions that will help you complete a certain task. So for example, I might say what is an algorithm that will help me get out of this room, right? So I can write out a set of instructions. First, I have to stand up, I have to turn around, I can open the door, and I can leave. Things like that, right? I'm not actually leaving. It's just way too cold out there. I'm not leaving. But then there's also more complicated algorithms. For example, you might have a list of numbers, and you might have an algorithm, a set of instructions that will help sort those list of numbers, for example. Now, algorithms doesn't have to necessarily be like a piece of code on the computer. It could just be simple lines of instructions. Say, first do this, and then do this, and then do that, and then if this happens, do that, otherwise do that, things like that. Algorithms, in my sense, is a lot more abstract than just like pieces of code on the computer. A lot of people probably describe algorithms in different ways. Maybe someone would describe it as a black box where you just input something and then out comes something else. But you know, there's many ways to look at it. Now, data structures is something very similar. It is basically sort of how you can organize a data that you have, or some set of data that you have, so that maybe a task that you want to do is a lot easier to be accomplished. So for example, suppose I have like a long list of numbers, right? And maybe I want to ask something like, what is the biggest number in that list, right? I want you to take out the biggest number in that list and then give it to me, right? So if you have a list, how do you do that? Well, if I want to leave the biggest number in the list, I can look through each of the numbers one by one, find the biggest number, give it back to me. But what if I want to do that maybe say 1,000,000 times? Then every time you have to look through each of the numbers, find the biggest number, give it back to me. That takes quite a long time, right? So maybe there are ways that you can organize the list of numbers that you have so that if I just want the biggest number, then you don't have to look through every single number one by one. Maybe there's a way you can organize the data so you can just look, oh, it's right here, give it back to you, move on. Things like that. So there are different ways you can organize the data so that you can accomplish a task quicker. Basically is the idea of data structures. How can you organize the data that you have so that it's a lot quicker to do different things? Now, in data structures and algorithms, you basically talk about two big things about like these algorithms and these data structures, or at least as I would organize it. The first is you talk about showing different things about the algorithms and analyzing the algorithms. So for example, you might have an algorithm on paper. There's many questions you can ask it. So you can ask, for example, does my algorithm actually work the way I want it to? How can I know that this algorithm that I have will, for example, sort the list of numbers that I have correctly? So then you start to go into proving that your algorithm actually does what it's supposed to. There's different techniques of proving the correctness of algorithms, and that's basically what you have to learn. How do you write out the proofs that shows that the algorithm works the way it wants? The second thing that you might have to worry about, which is as important, if not more important, is about the performance of your algorithms or your data structures. How fast or how efficiently does your algorithm perform? if you have an algorithm, like what's its speed, like how much time does it need to, for example, make a computation or get out an answer for a particular problem. There's many ways you can analyze algorithms. I mean, the most simple way that you might think of is to just take a stopwatch out and then, run your piece of code, time it, and then once it's done, stop it. It works, but there are a couple of sort of shortcomings of analyzing algorithms simply by absolute time. First of all is that your code, the code that you write, depends a lot on the machine that you run on. So for example, you might have one algorithm, but if you write your algorithm out in two different programming languages, the time might be different. If you run it on two different computers, then it might be different. Even if you run on the same computer, writing out the program in the same language, it might still take a different amount of time just because of how the computer works at that particular moment. And so there are different techniques in analyzing the runtime of your algorithms. And those are things like the asymptotic notations, big O's, big thetas, where you are trying to analyze how quickly your code runs, but more based upon how fast it runs depending on the size of the input, for example. And it's more of an analysis technique which doesn't depend on your implementation, just depends on purely the algorithm and the logic that your algorithm requires, those sort of things. And then once you understand, for example, how quickly your algorithm runs or how you can analyze your algorithms, you start to realize that, in data structures and in designing algorithms and these sorts of things, there are many things you have to consider because, some algorithms might take a shorter time to run. But then there are trade-offs that you have to make. For example, you might have to keep a few more variables, or you might need more memory in order to make sure that the algorithm runs as quickly. Or maybe some algorithms works really well in one particular case, but if it meets one of these edge cases, it will just break down and just take a really long time to run, for example. Now, in data structures and algorithms, you learn a lot about data structures and algorithms that has been implemented already in real life. So for example, in the sorting algorithm that I've mentioned, there are many ways you can sort a list. There are things like insertion sort or bubble sort, which are a lot slower but a lot more intuitive. But then there are things like quick sort or merge sort, which are theoretically a lot quicker in terms of runtime and stuff like that. And you learn about why some of these algorithms are quicker, those sorts of things. And then for data structures, there might be a lot of other examples as well. So things like stacks, queues. The example I gave earlier about you keep picking out the largest numbers possible there's actually implementation of that as a data structure is called a priority queue, where you always keep some structure, and that structure always has the property such that the largest number is always at the top, and once you take out that largest element, the table rearranges itself so that the next largest element comes up to the top instead. So you can always do these sorts of little tricks and get your code to run a lot more efficiently. There are also so many other things that you do talk about in data structures and algorithms. Some people will probably be mad that I'm not talking about graphs and all those stuff, but that's a whole different big thing right there. But one of the things that you do learn in data structures is you're learning about all these different data structures and algorithms, but you're also learning about how do you apply them into actual problems. And I think that's one big part that you actually take out from this class is you get to see loads and loads of different problems, and then you just basically throw into the sea and they say how do you go about solving this problem? You have to think about what data structures you already know, what algorithms you know, and then sort of try to take those and apply it into actual problems and all those stuff. And it's really, really interesting. It's a really fun class. It really gets your brain thinking, but also thinking about writing out code that is more efficient, not just writing out code for the sake of doing a certain task, but also think about how much time it will use or how much space, memory your code will actually use up and things like that as well. But basically that is it for my little ramble about data structures and algorithms. It's a great class, and thank you very much for watching this episode of 12 classes, and I'll see you tomorrow when I talk about another class that is sort of related to data structures.